Hello everyone, my name is Argenis Ramirez Gomez and it is my pleasure to be presenting Gaze+Hold on behalf of my co-authors Christopher Clarke, Ludwig Sidenmark and Hans Gellersen. Gaze+Hold is an eyes-only interaction technique that builds on the ability to close one eye while gazing with the other one to leverage the eyes as two separate input channels for direct manipulation. Gaze+Hold utilizes the closure of one eye to modulate the state of interaction while the open eye provides continuous input until the reopening of the closed eye. Eyes-only control is compelling for a wide range of contexts where other input is unavailable or inconvenient. Existing eyes-only interfaces are grounded on the use of the combined eyes and continuous gaze tracking for pointing that is complemented by discrete selections, for instance by other eye movements such as fixations and dwell time. These approaches have two key limitations. Firstly, they could create problems of feedback and unintended input, for example the Midas touch, as the pointer moves with every eye movement and there is no distinction of whether the movement was intended as a pointing action or incidental to viewing. Secondly, the use of the eyes is exclusive for either pointing or click equivalent actions. As a consequence, continuous direct manipulations are not well supported. For example, the eyes-only equivalent to a mouse movement while pressing a button to move an object has to be mapped to a succession of gaze interaction steps to first trigger the selection of the command, then the selection of the object, and finally the target position. In this work, we introduce Gaze+Hold to extend the expressiveness of eyes-only interaction. The key idea is to leverage the eyes as two separate sources of input to support continuous direct manipulation by delimiting the interaction states with the closing and opening of one eye, whilst continuous input of the open one controls the explicit interaction. Let's take a closer look at how Gaze+Hold interactions work, for example to enable drag and drop. First, the closing of one eye initiates input and selects the file. Then, the movement of the other eye provides continuous input to drag the file until the opening of the closed eye to complete the interaction with the drop. This draws a distinct design space and style of eyes-only interaction that we explore to showcase the utility and flexibility of Gaze+Hold with a constellation of example applications. For instance, selection and moving of objects, multiple object selection, menu navigation and selection, panning and scrolling, zooming or scaling, or navigation and teleportation, among other examples. These examples open up a design space for eyes-only interaction for which we distill key design considerations, such as the utility of the gaze input at the different stages of the technique, the relevance of its accuracy, position, feedback, and the use of one or both eyes to allow multiple states of interaction, for instance to enable the configuration of different states or grabbing of tools with the eyes. We invite you to find more information in the paper. The use of Gaze+Hold relies on one-eyed gaze as continuous input, raising usability questions from both a technical and a user perspective that we addressed in a user study. Firstly, due to the requirement of the user to keep one eye closed for the duration of input, the performance of Gaze+Hold is dependent on the user's ability to keep one eye closed while using the other for input, and the input's quality of the binocular tracking system when estimating gaze when only one eye is available. Moreover, we investigated the usability workload, and user preferences when using Gaze+Hold to determine how the choice of eye and eye dominance affect performance. For instance, whether there is a preference for using one eye over the other, and how this manifests in choices the user makes when interacting spontaneously. We conducted a user study with 12 participants to establish the practicality and effectiveness of the technique with 2 tasks. First, a drag-and-drop task resembling the multidirectional fit-slow task with 16 targets. We compare the performance of Gaze+Hold with the dominant eye and non-dominant eye against the baseline of gaze input with both eyes open, with manual activation of interaction states with a button press. This aimed to assess the trade-off in performance for gaining the advantage of gaze-only control. Secondly, we addressed the spontaneous choice of eye for Gaze+Hold with a realistic desktop application scenario in which participants had to use the technique to move files into folders. The results from the user study show how, as expected with binocular eye tracking, gaze estimates are less accurate when they are temporally based on a single eye, while the coordination of gaze with eye closing increases effort. Nonetheless, participants were as effective with Gaze+Hold as with the baseline of binocular gaze. Speed and accuracy were lower than with both eyes open, but users gained the advantage of relying uniquely on their eyes for input. Notably, all users were able to use Gaze+Hold with either eye closed, and the choice of dominant versus non-dominant eye for manipulation had no significant effect on performance, usability, and perceived workload. To finalize, we want to leave you with the key takeaways. First, the Gaze+Hold technique is unique in leveraging the eyes as separate channels for complementary input. Secondly, Gaze+Hold is not as fast as binocular gaze, but closure of one eye is highly effective for delimiting gaze input and switching between interaction states without needing other devices or modalities. Thirdly, our work shows that users are effective with Gaze+Hold, performing equally well with either eye, allowing flexibility to access different input modes as well as dynamic configuration of eyes-only control. Finally, Gaze+Hold opens up a new design space for eyes-only techniques and interfaces for which this work provides a foundation and key design considerations. We invite you to find out more details in the full paper and to stay in touch. Thank you for listening.